morning, this is Dr. Stanley Forrester for Southport Middle School Pre-Algebra. I'm going to give you a little short tutorial here on combining like terms and the distributive property. Just so that you know, we can just call this out right away. You see this little blue box where it says take notes? Those are areas where you should definitely pause the video as often as you need to get that information down into your notebook. All right, so let's go ahead and get started. You're already familiar with two-step equations by this point, but to review, these are equations of the form where we have some coefficient times x, or variable, any variable really, plus some constant equals another constant. Right, we have an example here, 3x plus 4 equals 19. Okay. We're going to come over here, and in order to isolate this term here, 3x, we're going to have to get rid of this plus 4. We're going to have to get rid of this constant term. In order to get rid of adding 4, we have to do its opposite. We have to add a negative 4. And so that's what we have here in red. Plus negative 4. And of course, if we do it to one side, we have to do it to the other. Okay? 4 plus negative 4 is, of course, 0. That's the whole point of adding the opposite of plus 4. Okay? And 19 minus 4, well, that's going to be 15. Okay? So we ask ourselves, okay, so do we have anything else that we can combine or move? No, that variable term is right there by itself. There's nothing to combine it with, and so we're at the point where we need to take this term and we need to take it apart. We have this coefficient 3, and we have the variable x. And the way we get rid of that coefficient is we divide, and I'm sure you already recognize that we're going to divide by 3, because 3 divided by 3 is 1. Okay, and 15 divided by 3 is 5. Okay, so here we are. We're back to taking notes. We're going to combine our like terms, and we're going to use the distributive property. A term. What do we mean by term? It's an algebraic expression that are separated by addition or subtraction signs. Okay, right there. 7x plus 5 minus 3y plus 2x. So how many terms are in the expression? In other words, how many things are separated by plus and minus signs? 1, 2, 3, 4. Now, there's 4 of them. So what are the like terms? Like terms are the ones that look alike. That's how we put it here. I want you to look at that, though, and I want you to say, what kind of variable does each of those have in it? This 7x, is there anything else there that has the x variable in it? This 5 doesn't have any variables in it, okay? And 3y, well, x and y aren't the same. It's not the same variable. But 2y, those are the same, and we can combine those. More specifically, terms are terms that have the same variable raised to the same power exponent. We won't get into like x squared terms and things like that right now. But just keep in mind that that's a possibility. Okay, so let's give it a try. Again, we have our take notes little indicator up, and we're going to combine some like terms. We have 14a minus 5a. Well, these are alike. All right, so let's say you had 14 oranges, and you gave away 5 oranges. You want to know how many oranges you have left. And so we're going to combine those coefficients. And again, the coefficient is the number that's multiplied by the variable. So how do we combine those coefficients? Okay, so 14 minus 5, those are our integer. We'll review our integer rules. These are, we're going to do keep, change, change. This is going to be 14 plus a negative 5. 14 and negative 5 have opposite signs, so we subtract, and we're left with 9. Again, 14 is the larger number. We keep the sign of the larger, so this is positive 9. That's exactly what you think. You had 14 oranges, you gave away 5, you've got 9 left. Okay. And again, 9a. All right, let's take a look at the next. See if you can identify the like terms first. See if you can identify the like terms first. And this one is a little tricky about the coefficients. There's one coefficient there that you have to kind of, it's implied. All right, so I'm going to pause, and when you're ready, start it back up. Okay, I'm going to identify the like terms. Coefficient of this here is 1 because 1y equals 1. Okay, and we simply don't write that 1 there. All right, so if we go ahead, we're going to identify those like terms. Those are the terms that all have y in it. But we also have these constant terms. We can combine those as well. Okay, so 7 minus 3 plus this implied 1 here, this 1y, well, that's 5y. And then 8 minus 1, that's 7. Right? So we've done that. So let's combine the like terms. Let's take a look at C and D and ask yourself, okay, so how many variable terms do you have and how many constant terms do you have in each of those? And then see if you can combine those. All right, when you're ready, pause the video, and when you're ready, we're going to move on. All right? So, identify the like terms. The coefficient of Q is 1 because 1Q equals Q. Okay, again, that coefficient of 1, we never write that coefficient of 1 in there, but it's implied. And so if you have 4 or something, you take away 1, you have 3. So it's 3Q. For the next one, we have how many variable terms? Yeah, that's right. We have 3 variable terms. And when we combine those coefficients, we're going to have 5 minus 4 minus 1. And we combine the constant terms, we have 8 minus 2, and that's going to be 6. Look at that. So 5 minus 4 minus 1, that's 0. So we have 0C. Anything times 0 is just 0. Okay? And in this particular case, once we combined all of those variable terms, the variable itself vanished. Okay? We haven't introduced it yet, but that's going to be a very important property of some of the equations. Now, notice that these are expressions, not equations, but we can have, this could be part of an equation. And if the variable disappears in part of an equation, that's going to have a property that we're going to discuss later. But, okay, so the variable itself disappeared, but we do have these constants. They're non-zero. And off we go. Okay, so let's combine the like terms. Ask yourself, how many similar terms, how many like terms does that expression have? Well, say, this has the variable m, and there are no other terms that have the variable m. This one has the variable n. There are no other terms that have the variable n. This is a constant term, and there are no other constant terms. And so that's what we had. There were no like terms. On this one here, 5m minus 7m. Okay, so pause for a moment. Ask yourself, how are you going to combine that? How are you going to combine that? Take a look at those coefficients. This is 5 minus 7. How would you combine that? Yeah, keep, change. You keep 5, you change the subtraction to addition, and the plus 7 becomes a negative 7. So 5 plus negative 7 is negative 2. Okay, and negative 8 plus 4 is, of course, negative 4. Right there, just like that. Okay, so when we say simplify an expression, we mean perform all possible operations, including combining like terms. Okay, in other words, we're going to simplify means solve, or at least solve as far as you can. Sometimes there's no equal sign. If there's no equal sign, you can't actually solve it, but you can make it a little simpler. All right. So next we're going on to the distributive property. This is an algebraic property which is used to multiply a single term and 2 or more terms inside of parentheses. Okay. When we were combining terms, we kind of have to have them all separated by those plus and equal signs, and it's not always quite that simple. So for any numbers a, b, and c, we can have a times the quantity in parentheses, b plus c, equals a times b plus a times c. Seems, okay, that's a little abstract, okay? So notice there's a no take note sign. Okay, so just think about that for a moment. And when we talk about trying to combine terms, notice that these are separated by a plus sign. This is this times that, just like a coefficient times a variable coefficient. Okay, These are terms that we can combine. This we can't. Not until we've actually used the distributive property. Okay? There's also another one here. A is times B minus C is equal to A times B minus A times C. Okay. So this is where we have our notes again. Distributive property means A times the quantity B plus C equals A times B plus A times C. Now, pause the video. Write that in your notebook. Put a box around it. Put stars around it. You need to know that. Okay, the distributive property. Let's throw some numbers at this and see if we can see an example that's going to give us some confidence that it actually works. Okay, we're going to use the specific numbers 2, 6, and 7. Every place we see A, I'm going to put in a 2. Every place we see B, I'm going to put in a 6. Every place we put in 7, or I'm sorry, C, I'm going to put in a 7. Okay, so this is our statement of the distributive property, and that's going to become this statement here. Again, every place I see A is going to be a 2. Every place I see B is going to be a 6. And of course, C becomes 7. Okay. But we'll give us a little bit of room here. And let's take a look at this. Okay, so 6 plus 7. Okay, again, by our rules, we have to do whatever's in the parentheses first. 6 plus 7 is 13. All right, that's what's over on this side. So this is 2 times 13 on that side. Over here, 2 times 6 is 12, and 2 times 7 is 14. 2 times 13 is 26, and 12 plus 14 is 26. Okay, that's a true statement, okay? And that gives us some confidence that we can use the distributive property, right? Now, we can't test that for every single number because there's an infinite number of, well, there's an uncountable number of numbers, okay? But if we throw a few examples at it, we can gain some confidence in it, okay? Now, again, we have our take notes, so we're going to distribute. And I want you to go ahead and do this on your own. Pause the video right now. All right? And, okay, when I say pause the video and carry out that distribution. Figure out what this whole expression looks like after distributing. Okay? Note, these are not equations and they cannot be solved. Resist the temptation to insert an equal sign. All right? I know it's really tempting to just think, okay, this is all going to be about solving for x. Okay, right now we're just carrying out distributions so that we can, if this were part of an equation, then we would distribute, and then we would solve. But right now, there's no equal sign there. Okay? Now, when I say pause, pause. Pause. Okay, and we're back. And I assume that you've done your work. So let's take a look at this. Okay, this is 6 times x, and 6 times negative 3, so that's 6x times 18. Okay, negative 2 times y is minus 2y, and minus 2 times 1, well, minus 2y plus negative 2. Okay, negative 3a, and now this one's a little tricky. Negative 3 times negative 1, that's going to end up being positive. Now we're going to use the distributive property first and then combine like terms. In other words, we're going to take these skills that we've learned and we're going to put them together. I'll do the first 2. You'll do the next 3. All 5 should be in your notebook when we're done. Okay, so again, we have our take notes indicator. Simplify. 6 times the quantity, 5 plus n, close parenthesis, minus 2n. Okay. First thing, okay, that's our expression written out. We're going to distribute. Take 6 times 5 and plus 6 times n. Then we're going to multiply. So 6 times 5 is 30, and 6 times n is just 6n. And we didn't do anything with this thing here because it wasn't in parentheses. We didn't need to. Let's go ahead and let's combine the coefficients of our like terms. Notice this term here has an n in it, that has a term that has an n in it. If you've got 6 of something, you take away 2, what have you got? You've got 4. Okay, and it's 30, oops, 30 equals 4n. Okay. Now pause that if you need to before we go on to the next. Okay, simplify. 3 times the quantity in parentheses, c plus 7, and then from the whole thing we're going to subtract c. Notice that there's a variable in here. We can't combine this term here with anything while it's stuck inside those parentheses. So, first thing we have to do is distribute. Here's our original equation. And then we're going to take 3 and multiply it by c, and then 3 times 7. See right there, 3 times 7. We know what that is. 3c plus 21 minus c. Now notice that we have 3 terms here. 2 of them are variable terms. We're going to combine the coefficients. 3, and again, this negative, we're going to call that a negative 1 there. Okay, so 3 minus 1 equals 2. In other words, you could say, you got 3 oranges, you take away 1 orange. How many you got left? That's right, you've got 2 oranges. All right, so 2c plus 21. All right, now it's your turn. Simplify these. Show me your work, and then we'll go over them, okay? So that's enough for right now. I'm sure you've got plenty to do.